In this video, Graphing Basics Part 4, I will show you how to find an input given an output. For the function f of x equals 2x minus 5, we're looking for the values of the, we're looking for the input x for when the value of the function is 0, -2, 15, and 4. So to start out, make sure that you have all the plots off. You have your y equals blank, and go ahead and set your window to a standard window that also reflects your values that you're going to have. So for example, here I have my window set to -20, 20 for the x min, so that means that my inputs can't be less than -20 and can't be greater than +20, and my y min, my output values, cannot be less than -20 or greater than 20. Now for these ones, just looking at this quickly without doing any sort of mathematics or substituting in, I can see that my y, or my output, the y min, y max, is going to be okay for the values that I have chosen. That I have given. Let's go ahead and get started. Window's okay. Let's go back to y equals and enter in our function. We're going to say 2x, we're going to use this button, x minus 5. That's our function. Now, we want to use the intersect function on the calculator, which means the calculator is going to graph two functions, then find the intersection of them. So, I'm going to say that my other function is the horizontal line through y equals 0, which in this case is the y-axis. So we're going to go to the intersect feature, which is second, trace, which is calc, and go down to intersect. And then we're going to see our two graphs. Well, you're not going to really see your second one. Your first one, even though it says first curve, this means m is the first function that the cursor is on 2x minus 5. And yes, that is, because that's one of the functions I want my calculator to use. Is the second one y equals 0? Yes. And then the calculator is asking me, do I want to guess the intersection of the two curves that I just told the calculator to look for? And I said, yes, I do want you to guess. How'd you know? And so now we have the intersection as 2.50. So I'm going to go ahead and write that down so I can kind of explain to you what this means. The intersection of these two equations is 2.5 and 0, which means that when the output is 0, the input is 2.5. So when the value of the function is 0, x is equal to 2.5. Now I'm going to repeat this process for every single value, giving you a little bit of tips as I go. Let's go back to y equals. Now, some of you guys might want to just continue down using y3, y4, y5, but I'm going to go ahead and keep this really nice and clear and clean on the video. So I'm going to go ahead and erase and clear out. I push clear to clear the 0, and then I'll put in my next value of the function, -2, into my y2, and then I'm going to look for the intersection. Now what I'm looking for on each one of these is the intersection in the window? If it's not, then we're going to have to do something else. So yes, the intersection is in the window. We can see it right here. That is going to be the intersection. And again, the calculator is asking me, is the first function, or is the first, they call it the curve, I'm calling it the function, is the first function 2x minus 5? Yes, it is. How'd you know? And the second function, is that y2 equals -2, as in y equals -2? And yes, that is, because that's the other value that I wanted to find. So I'm looking for what is the value of the function. The value of the function is -2, and what is my input at that value? And so I'm going to say, well, gosh, you're so smart, calculator. How did you know that was the second curve? And then the calculator is going to ask me, well, do I want to guess the intersection of these two? And I say, yes, I do want you to guess that. And so now we get the intersection as x equals 1.5. So I'm going to continue this. Okay, so y equals 15. Okay. Oh, hold on a moment. Forgot to clear that out, sorry. Okay. And now we have the intersection is shown at the window, so that's fabulous. I'm going to go ahead and change this to 40 actually. Okay. And we have that the first curve is y equals 2x minus 5. Yes, the second curve is y equals 15. Yes, and the intersection of these two, yes, I want you, calculator, to guess that. Guess that for me, calculator, go. And the intersection is 10. So when the value of the function is 15, then the intersection is 10. Sorry, the input is 10. Now I went ahead and I changed my other value to 40 because I wanted to show you how you need to adjust your window. So a case where you need to adjust the window. Okay, so going back to the window, this value is not going to work for the window. If I went to actually, like, let's say I was not thinking straight and I went to go put in the value of 40 and then I went to go do my intersection, I can't see the straight horizontal line through the value of 40 because it's not in the window. The value of 40 is not in the window. So go back to the window and adjust the y max. Now those of you who know what I'm doing, this might seem a little bit slow, but I'm just going to adjust the y max. Okay, then I'm going to check again and again. Is the value going to be in the window? And no, look, the intersection is still not in the window. It's the input for the value of the function at 40 is not less than 20. So I have to go back to the window and I have to increase this as well. So I'm going to go ahead and increase this just by 10 and let's see if this works. Okay, now we have the intersection in the window. If the intersection was not in the window, then your calculator would give you an error. Okay? If the intersection is not in the window, your calculator would give you an error. First curve, yes. Second curve, yes. Yes, I want you to graph it, calculator. Thank you. How'd you know? And the intersection is x equals 22.5. So things to keep in mind, adjusting your window. If you can't see the graph, you want to use the concept of intersection of a horizontal line and your function in order to find an input for any given